Okay, so we are starting Unit 3. This chapter is on congruence. We're going to start off just with some Polygon vocabulary today, and specifically we're starting with triangles. This is a review of what you may have done in elementary school, like how do you classify a triangle. So an example to classify a triangle by angles would be we have an acute triangle. Remember, acute means less than 90. You have a right triangle. A right triangle includes a 90-degree corner. You have an obtuse triangle. Obtuse triangle has to have one angle that is obtuse. In an acute triangle, all three acute angles. Whereas in an obtuse triangle, you need one obtuse angle. In a right triangle, you need one right angle. Okay, and the last one you probably have heard of is called equilateral, angles, so equal angular. That means all angles are equal. And if you think about it, a triangle adds up to 180 degrees with their angles. So if all the angles are equal, 180 divided by 3 would mean each angle is 60 degrees. So a equiangular is a special type of acute triangle because all the angles are 60 degrees. Okay. Classifying by sides, this would be familiar probably, scalene. A scalene triangle has no equal sides. Then you have what's called isosceles. An isosceles triangle has two congruent sides. And then if all the sides are equal, we call that equilateral. All sides are equal. Alright, so angle choices are acute, right, obtuse, and equiangular. Side choices would be scalene, isosceles, or equilateral. So this first example says classify the triangle by the angles. Okay, so CDE. When you follow the letters, it creates a triangle. So CDE would be this triangle here. This is the triangle symbol in front of this. So triangle CDE has a little right angle in it, so we'll call that a right triangle. Okay, BCE. Do that one in a different color. BCE. That is that triangle right there. You'll notice in this one it doesn't give me any measurements. So if you look at angle C, I would say this angle here looks more than 90 degrees. So if it's over 90 degrees, we're going to call that an obtuse. Because that's an obtuse triangle, obtuse angle, so it will be called an obtuse triangle. And the last one is ABE. If you look in this picture, ABE, hopefully you'll notice in this picture you have the congruent symbol in the corners of that triangle. So that means all the angles are congruent, so we're going to call that equiangular. That one happened to work out. I could color like each of the triangles a different color. A lot of times though, like if I asked for a triangle, maybe BED, sometimes your triangles will overlap each other, but that's just how you classify by angle. Example 2, we're going to classify by sides. So our side choices are scalene, isosceles, and equilateral. Remember, these little marks on the side tell me which segments would be equal. Alright, so JKM. JKM is talking about the entire big triangle here. So JKM, this has one mark on it, but that side's not congruent and that side's not congruent. So we're going to call this one scalene. Okay, then we have KLN. KLN is this triangle in there. that triangle has that these two sides both have two little marks, so those two sides are congruent, so we'll call this an isosceles. I just don't feel like writing out the word triangle, so a lot of times I just put the triangle symbol. And the last one, JKN. So, JKN. That is this one here. So, JKN, you'll notice these have three little marks that are all the same, so we're going to call that equilateral. Alright, the next section, these are just some vocab words that are in geometry books and you might see later in other math classes, so I just want to point them out. We've learned that the word perpendicular means something forms a 90-degree corner. That's what this little box means. This line is going to be perpendicular with this side. And you'll notice the word bisector. Bisector means, hopefully you can see it's a little light, but this is congruent to this. So this perpendicular segment bisects that segment, which means it cuts it in half. That's called a perpendicular bisector. An angle bisector, we did this one in Unit 1. An angle bisector would be this line here. It is cutting this angle in half, so you'll notice they put those little marks in the corner to show that that was cut in half. A median, it goes from a vertex, and it bisects the other side, so it cuts this side in half. So we could say from a vertex, and you could say to the midpoint. How about to a midpoint? So from a vertex here, a corner, to the midpoint of the other side. So that creates two equal segments, or this segment bisects that segment. The only thing different on this one and the first one is this one doesn't have to be perpendicular. This one has to be perpendicular. Okay? This one doesn't have to go from a point, but this one does have to go from a point. Alright, an altitude. An altitude is a line that from a point is perpendicular to the other side. Straight. So it's perpendicular, and it's from a point, or a vertex. Whereas the first one we did, this is perpendicular, but it doesn't have to be from a vertex. It's just perpendicular, but it bisects. These on this side are much more complex ones. The ones we are wanting you to be able to draw would be any out of this first column. So we are only expecting you to be able to draw these. As far as homework and test goes, is just could you draw those four different types. These types over here are different ones we do in geometry. They're just a little more complex. You will get to those probably later on in other classes. We're not going to focus on those, even though they're in the geometry book as well. Alright, the next question on this page is, what is the correct classification by sides of a triangle with these ordered pairs? In order to do where it says by sides, we would need to know how long each side is. We use the distance formula to find the lengths of sides. So your distance formula So there's our distance formula. We're going to just pick 2 points to do at a time, like we did with perimeter, only this time we just need to know the lengths of the sides instead of actually adding them all up. So let's do A and B first. Remember, this is like your x1, your y1, your x2, and your y2. So 2 minus 3 squared. Oh, sorry, do not do that. My bad. Let's just start that over. I've been doing slope a lot in my Algebra 1 class lately, so let's go back and start with the x's this time. I'll give that a second try. Let's go ahead and do B and C next. So let's do your x's. My x value would be 2 minus 3 squared plus negative 2 minus 2 squared. Picking my x's first and then my y's. You do parentheses first, so this gives me negative 1 squared and negative 4 squared. 1 plus 4 squared is 16, gives me square root of 17. Okay, I'm going to go back and do AB now. Hopefully that's a little bit drier. Your x's for this one would be 3 minus negative 1 and 2 minus 3. So remember, I get lazy sometimes. I don't write the square root sign until the very end. Just remember that's under a square root there. So I did what's inside the parentheses. Now I'm ready to do the exponents. 16 plus 1 equals square root of 17. Well, we know it's either going to be equilateral or isosceles because we have two of the equal sides already. So let's try the last one of AC. Cross line, change sign, so you get 3 squared plus negative 5 squared. That's 9 plus 25. Well, it's not going to be 17, so that comes out to 34. So, in this case, I have two sides that are the same. If two sides are the same, we're going to classify this as isosceles. So if no sides come out the same, these are my sides. If no lengths are the same, it's scalene. And if all the lengths are the same, then it's equilateral. Alright, so the answer to this, you share your work, find your lengths of your sides, and then classify it by those sides.